Hi. Um, Good people. This is Mudupi, the genius, all the way from Lady Brent. I am the founder of Genius Tuition Institute and a tutor. So, as you are now in grade 12, you are just one step before you can reach your tertiary, and you are the last step in your secondary education. So guys, in mathematics, especially when you are in grade 12, you are going to have only 8 months. That is from January up to August. In August, your syllabus must be completed because you're going to sit for September, which is the trial examination, and thereafter you are to sit for the October final examination. So guys, we need to work. We don't have time. So this is our online classes, guys. So everything that we are going to do here needs internet connection. So I will also advise you to download Telegram as well as Skype, because on weekends, but I will tell you, on weekends I want to communicate with you using Skype. So let every one of you have Telegram as well as Skype on your devices. So guys, let's begin. We are now going to deal with sequences, and I know this is a revision from grade 11. So what is a sequence? A sequence is a list of numbers following a constant pattern. So what type of sequences do we have? For now, we need only 3. That is arithmetic sequence. This is also known as linear sequence. Now, this sequence has a constant difference. That is, the first difference between two successive terms is constant. If you have that, you must know that it is an arithmetic or linear sequence. Now, the second sequence is geometric. Now, what is geometric? A geometric sequence is a sequence where you have the first constant ratio. That means you are now, in order to get the constant ratio, you are going to divide term number 2 by term number 1, term number 3 by term number 2, and that should be constant. A ratio is a quotient. So in order to get the ratio, you have to divide. Now, division goes hand in glove with multiplication. So in order to get the successive term, you have to multiply the previous term by the constant ratio. That is in geometric. But in arithmetic, we deal with the difference. What is the difference? The difference is an answer that you get when you subtract. Now, subtraction goes hand in glove with addition. Now, in order to get the successive term, you have to add the constant difference to the previous term. That is how we differentiate the arithmetic to the geometric. So guys, that is the difference. Now here we said you must have a constant in order for that to be a linear or arithmetic sequence. There must be a constant difference, in your first difference. For this one, that is geometric, you must have a constant ratio, and that must be in the first line. That is the first ratio. Then, lastly, we have this one, quadratic sequence. Now, this comes from quadratic. We know quadratic equation. If something is quadratic, it's four-sided. Quad means four. So when we deal with the area of a four-sided figure, that will be length multiplied by breadth. And then if you have a binomial x minus 3 and x plus 2, that will be x squared minus 5x, then plus 6. Oh my God. That's it. And that is a quadratic function. Now, all quadratic sequences are based on quadratic functions. All arithmetic sequences are based on linear functions. And then the geometric sequences are based on exponential functions. Guys, this is awesome, because we take it from a definition and then we move it to a representation. How can we represent the arithmetic sequence? You can represent that as a straight line. Let's do this. It can be a straight line. This is linear. It's linear. So what about this geometric? When we deal with geometric, it's exponential. Let's have this. Okay, the first one, it's linear. That is arithmetic. It's linear, and normally we need a gradient in order to draw a linear. This is linear. Then in order to draw that, we need one, that is the gradient. And let me show you something, guys. That gradient is always, the constant difference. Hey, some people will say, hey, Dupes the genius is now kaput mad. No, that is it. And now, on the second, you have geometric. And what is the function of linear? That is Tn is equal to a plus d, a plus n minus 1d. And then here we have Tn is equal to a into r, to the power minus 1. ar to the power n minus 1. And then this is it. So I just write it there. I know some of you cannot see it, but you will. Now, when it comes to quadratic, this is quadratic. When it comes to quadratic, let me do this. When it comes to quadratic, you know what a quadratic function is. A function. Now, it's in the form y is equal to ax squared plus bx, then plus c. Look at this. This tells you that this should be quadratic. So, in a quadratic, guys, you must have the second constant difference. That is how it is. Now, let's take them one by one. Let's take them one by one. Now, arithmetic. We have said the general, that is, the general is y is equal to mx plus c. Now, this is a well-known linear function. Linear function. Linear function, fine. But when it comes to the sequences, we are going to write it differently, but using this. Instead of writing y, we are now going to use tn. We use tn. Tn. Yeah, let me do this. Let me write it here. It will be, let me write it here. It will be Tn is equal to, yes, Tn is equal to A plus, look at that, A plus D, n minus 1 then multiplied by D. Now look at this. I just want to show you something, guys. If you look at this, this is n minus 1. And then this is the constant difference. The constant difference here. And the constant difference is going to be m. It's going to be m. And then what about your c? Your c is that. That is your constant difference. Your a will be constant. Right? Now, okay, let's take this one. You have 23, 25, 27, and then what type of a arithmetic sequence is that? We have the last three dots. You have 23, 25, 27, and then dot, dot, dot. What does that mean? This is an infinite sequence. If you were having it like that, 23, 25, 27, that was a finite sequence. Because the last one will be 27. But if it's like this, it's infinite. You have infinite numbers. Now, when you move forward with this, you are going to determine the sum of the sum of finite sequences. And again, you are going to find the sum of infinite sequences. Especially when we deal with that, we are going to focus on geometric sequence. Then, look at this. Normally, this will be term number 1. That is term number 1. And then this will be term number 2, term number 3. Normally, term T1 is referred to as A. So our A is 23. This will be term number 2. And then, in order to get our D, which is a constant difference, we are going to subtract term number 1 from term number 2. That will be 25 minus 23, and that gives us 2. So guys, our constant difference, we say it's constant because it will never change. 27 minus 25, that is 2. So the next one, in order to get the next, using this, you are going to add this. 23 plus 2 gives you 25. 25 plus 2, 27. Now, on your examination paper, you are going to get this. And please listen to me because I know what I'm talking about. The question will be asked. You'll be given 23, 25, 27. And then the first question will be, write down the next 3 terms. You know what you do? The question says write down. Don't calculate. You don't show your calculations. You just write down the next. How do you do that? You are going to do this not on your answer sheet. You're going to get your constant difference, and then you're going to add 27 plus 2. The first one is 29. The second, 29 plus 2 is 31. And then plus 2, 33. You just write 29, 31, and then 33. That's it. And it's normally 1 mark. So guys, this is it. Now I am going to give you a task. It's like an investigation that you are going to do online, because we are online. You visit your Siyavula Read online book, and then chapter 1, EMCDP. Then you click on visit video. You click on that. Click on visit video. That is chapter 1 EMCDP. Click on visit video 284G. You click on that and then listen to that guy. You listen attentively, and thereafter you do this. Task number 1, this is it. You do exactly that, and then you do this. Exercise 1.1, then you do number 1. The rest of it, 1, 2, 3, etc. And then you move to exercise 1.2, 1, 2, 3, up to 11. Up to 11, guys. You do that online. And then just make sure that if after completing that, click on show the answer. You don't click on show the answer before you write it down. That is cheating the wrong way. So guys, that is what we need to do for now. And then I will also like to congratulate every one of you for having passed grade 11. And I am sure that you are motivated to be where you are. And I know that there is a genius in you who needs to be unleashed. Now, my purpose and objective is to take that genius in you out of you. The genius in you has been on hostage for 11 years. Now is the time for him to be unleashed. So this is our task, me and you. And I know we are going to make it happen, willy-nilly. So please, guys, show your parents this video and show them the classes that we have. These are virtual, they are called virtual classes because we don't need the walls to have a school, but we need our smartphones because we are using smart education. Everything is smart. the fourth industrial revolution has landed, and we are the first. I know we are the first to do this online. And please go through your back office. There's a video there which is entitled The Future of Learning by Professor Shugada Mitra. Show that video to your parents, guys. In order to change how they think about your devices, that is your phone and your laptops. They will never see it as a hindrance to your education, but they will see it now with new eyes and new brains as a tool to enhance your development, educational development. So guys, this is it. From me, Dupes the Genius, all the way from Lady Brand, Free State. Thank you guys. And make sure that you spread this at your schools, guys. All those who are having the Telegram link, spread it. And make sure that you send them my details, that is the WhatsApp and a call. Send them my numbers, my contact details, so that they can be added in the classrooms. So by so saying, I would like to say thank you, thank you, thank you guys. Thank you.